Hello everyone. Thanks for being here this afternoon. Appreciate it's been a long day. We're all still here. Fantastic, thank you. Look, my name's David Williamson. I'm with the Reef Authority. I've been there for the last 3.5 years. It's been a great run there, really thoroughly enjoying my time with the Reef Authority. It's been fantastic. And I've had the great pleasure of looking after the COTS Control Program over these last years. And seeing the development that we've been able to create within the program has been a real pleasure. So this is Mary. I think you all know Mary by this stage. They've asked me to talk a little bit about where I'm from and what brought me to this. Look, I grew up in WA on Noongar country, and that's where I developed my connection to the sea. I started fishing and diving and spearing and stuff when I was a kid, and really never stopped, and eventually figured out how to turn it into a career. And 30-something years, 40-something years later, here I am. And so, yeah, look, it's been a fantastic journey. But like I said, the last 3 to 4 years working with the Reef Authority and with the COTS Control Program has been a real pleasure. So, look, we're going to talk to you about the value of integrating science into management. And I don't think there's any other example that I'm aware of anywhere in the world where we've got a marine conservation program of the scale that the COTS Control Program is, in which we've got such systematic integration of science and knowledge into our day-to-day, year-to-year decision-making. In terms of the strategy of the program, our tactical deployment of our resources, I'm not aware of anything else that does it the way we do it. So fundamentally, the research that underpins this program stretches back decades. But we're continuing to double down with that research now, and we're continuing to invest in research that really is applied and focused on delivering outcomes that integrate into improved management decisions for the reef. Okay, this is the go button. Before we get right into it, I'd obviously like to acknowledge the traditional owners of the land and sea country on which we live, work, play, pay my respects to elders past, present and emerging, and shout a special thanks to Gudju Gudju and the Yirrakanji, Yidinji traditional owners who've given us such a warm welcome to their country this week and facilitated such a successful symposium so far. I think it's been a great week, so thanks very much to the local TOs for welcoming us to country. Appreciate it. Okay, look, either I stole some of Roger's slides or he stole some of mine. But look, so I deleted a few bits off this one, but essentially the story is that climate change impacts are ramping up pretty quickly now. We're seeing it and it's unfolding in real time right now. We obviously need to double down and do everything we can at local scales to keep more coral on the reef right now. Number one is protect what we've got. And when we look at the three major drivers of coral dynamics on the park, across the park, it's cyclones, storms, bleaching events and COTS. The only one of those that we can actually manage or control at scale is COTS. Now, in recent years, I don't know if any of you saw Sam Matthews' presentation just a little while ago in this room, but we've got some really clear coral protection outcomes to the program. And I'm actually a strong advocate for transforming the name of the COTS Control Program to the Coral Protection Program. And I think that's something we should do moving forward. So protect what we've got, allow natural adaptation processes to occur, restore where we need to, adapt again, and keep it moving forward over these next decades. I think that's the path. So without labouring that too much, I think obviously COTS, they're highly evolved. They've been around for millions of years. They're native to the Great Barrier Reef and there's several species across the Indo-Pacific region. They are highly voracious, highly effective coral predators, as you're all aware. They also reproduce in massive numbers. So when we get a spawning of even relatively low numbers of COTS on any particular reef, their larvae can disperse tens to hundreds of kilometres and reseed, replenish other reefs with COTS populations and propagate these outbreaks as they move through the marine park. Of course, the GBR Marine Park is not sitting here in isolation. We're connected by larval connectivity to the Torres Strait, to the Coral Sea, to the reefs of southern Papua New Guinea. This is operating on a broader scale than just the GBR. So increasingly as we move forward, we need to think about the scales over which we're managing and work with our partners nationally and internationally to do more. So obviously when COTS reach outbreak densities, they become a real problem for reefs. We lose coral very, very quickly. We degrade reef condition, obviously productivity of the reef, and everything drops. We lose not just coral cover, but also species. And that's a paper that's published. That figure on the left is a paper that Morgan published back in 2010. And essentially it shows that we lose coral and we lose species as COTS density increases. So it's not just about the fast-growing, shallow stuff that obviously drives recovery that we've seen in recent years. It's not just the acropora corals that these things are targeting, particularly when coral starts to drop. They will be much less selective in what they're feeding on. And obviously, if we lose a coral that's been sitting there for 40, 50 or 100 years, it's going to take us 40, 50 or 100 years to grow another one of those. So yes, they do preferentially feed on acropora and some of the other faster growing species, but they eat other things when those faster growing stuff is not around. So some interesting pictures there. Recently come across that PPE was not what it is now. But obviously traditional owners have known about COTS outbreaks for generations. People would have observed them up on reef flats back in the days when many reef flats were covered in coral. So they would have observed COTS, they would have seen that the numbers were booming, and they would have seen that coral was going down when numbers boomed. For whitefellas and Westerners, the first documented outbreak on the reef was in the 1960s, right out here at Green Island and places like that. And people obviously realised straight away that these things are eating coral, we need to do something about this, what can we do to protect our important tourism sites and places where we all go on the weekends and enjoy our time. So they put a fair bit of effort into trying to figure out what they could do about it, right? So it started off with people just spearing the things, pulling them out of the water, realising they were really venomous and awful to deal with, taking them to the beach, burning them, burying them, trying all sorts of stuff that really wasn't particularly effective, but could probably keep them suppressed at pretty small scales. So as we've gone forward, obviously there's been a whole lot of foundational research that's gone into understanding the biology of these things, the ecology of them, and also giving us greater scope on the scale of the problem. Us understanding how outbreaks actually move through the park. AIM's long-term monitoring program has been absolutely pivotal since the 1980s in understanding these outbreak dynamics and how that relates to coral dynamics across the park as well. Now, that animation on the left is based on the LTMP monitoring data from 1985 through to 2017. It's showing you that those outbreaks, according to that data set, are essentially initiating on reefs in the vicinity of Lizard Island, between Lizard Island and Port Douglas. As we've marched forward and we've got more data from more areas, we're realising that there may be more than one initiation area of these outbreaks. And in fact, this current initiation area may be further north than what we once thought. So Morgan Pratchett again and team are doing some really interesting work in that space. And interestingly, up in the Torres Strait, we have an outbreak underway right now, and TSRA are looking to mobilise COTS control in the Torres Strait, largely learning from what we've learnt here in the GBR, but applying some of their own unique attributes that they need to in the Torres Strait. So we will see increasingly coordinated COTS control efforts across the northern boundary of the Great Barrier Reef Marine Park. So I'm looking forward to helping TSRA and working with them to deliver that. Now, we are currently in the fourth outbreak of these things since the 1960s. Each one of those outbreaks lasts somewhere around about 15 years or so. We know that this zoning plan that we've had in place now in 2024, the 20th anniversary of the zoning plan that was introduced in 2004, has generated enormous benefits for the marine park generally, in terms of fish populations, coral protection, direct and indirect coral protection effects, plus crown-of-thorns starfish outbreaks. So we see lower densities of COTS, so less per unit area on reefs that are closed to fishing versus those that are open to fishing. And we also see that protected reefs, green zone reefs, are less susceptible to outbreaks than reefs that are open to fishing. So those two things together are pretty important outcomes of a zoning plan, right? It's in some ways it's exceeded the basic expectations that we had of this thing when it was put in place in 2003. And this wasn't the first time we did zoning. This had to be scaled up from what was introduced in the late 80s, when we had only 5% of the reefs in the marine park protected as no take. We now went to about a third of the marine park protected. So it was an outstanding step, and hats off. I can see John over there, one of the pivotal people involved in that process. So thank you for the work you did back then, because it's really generated and continues to accrue benefits now. So yeah, well done. So techniques have changed. That photo on the left there is Bob Endine in the 1970s. Developed an electric shock device for starfish. I don't know how that worked with divers in the water, using electricity. Anyway, interesting. We tried a lot of things. We tried running lines of quicklime across the reefs to try and fence them into certain areas. We tried netting them, trapping them, all sorts of things, none of which were particularly effective. Obviously, picking them out of the water and moving them was dangerous and slow and just totally inefficient. It was really when we started injecting them with chemicals. But the early injection methods actually involved multiple injections. You had to inject every arm. Some starfish have 17 arms. It's a lot of time. For every extra seconds and minutes that those divers having to work on an individual starfish makes it less and less effective. So the single shot technique, and we use household vinegar, of all things, the cure-all. And that was since only about 2013, 2014. As well as that, ox bile salts in solution is another chemical equally effective. And that photo, that ugly looking blob of beige you can see at the bottom there, is a starfish that was injected with 20 mils of vinegar on a reef offshore Townsville last year, and that's within 24 hours of being injected. So very quickly they go into shock, I'm sure, and start to die and decompose very, very quickly. They're then eaten by crabs, fish, and all sorts of other things that like to get into them. Now, I've got a photo of the COTS spot up there, and there has been a bit of a misconception over years that we've got teams of robots out there doing this COTS control. No, we don't, just for the record. It's humans. And unsurprisingly, humans are pretty damn effective at overfishing things when we put our mind to them. Yeah, so yeah, look, you know, COTS control divers, they're amazingly effective. We've got about 120 of them employed across the fleet at the moment. So this program is a big employer of people as well. Included in that is huge opportunities for traditional owner involvement and participation in the program. There's been a lot of capacity building work that's been done. Collectively, it's been an outstanding program for many reasons, not just the coral protection that it generates. An exciting area of research that's currently funded under the COTS Control Innovation Program, and Mary will talk to you more about that soon, is some fairly pioneering research in semiochemical work, which is essentially trying to generate baits or attractants that may be effective for crown-of-thorns starfish. And if we can concentrate them at certain areas of the reef, it may make them much more effective and efficient to cull. So this is still in the future. And I'm not saying we may not have a robot in the future that helps us do the job, but for the foreseeable future, we've got humans doing it. Okay, so the COTS program objective, of course, is to protect coral. We're not trying to eradicate these animals. They're a natural part of the ecosystem. All we need to do is suppress their numbers to levels that are sustainable for coral growth and recovery. Essentially, coral needs to grow faster than the rate at which the crown-of-thorns starfish are eating it. And it's a pretty simple objective, right? And you can see that if I click that button again, which I should have done before, you can see the expanding spatial footprint of the COTS control program on that map on the right. From the early 2000s, we had one vessel on the water. It was largely led by AMPTO. I don't know if Gareth's in the room still. Hi, Gareth. But yeah, it was led by AMPTO, and they were really focused on high-value tourism reefs. And it expanded slowly, and they worked reefs offshore Cairns, Port Douglas, and down in the Whitsundays. But it was really not until fairly recently where we've had a much greater level of capacity in the program. We've had 3, 4, 5, 6 vessels currently in the program, and we're able to action reefs right throughout the marine park. So you can see with 6 vessels in 23, 24, we're actually able to action somewhere in the ballpark of 150 to 200 reefs in a year. And they are not just site scale impacts. These are entire small R reef, individual reefs, clusters of reefs, regions, and broadly across the marine park. So it's proving very effective at scale. Now, the timeline during this current outbreak, during the 4th outbreak that started in about 2010, has moved pretty quickly. Of course, we've seen some big developments. We've mobilised additional resources. You can see the number of vessels across the bottom of the slide there. But it's been, importantly, driven by important advances in the science. And one of them is the IPM strategy that was put in place by Cameron Fletcher is here, thanks Cam and team. So that work was funded under the National Environment Science Program from 2014 onward, and really was a step change in terms of how we systematically control individual reefs. It didn't tell us which reefs to go to. That's a separate process that we run. It told us what to do when we get to those reefs, right? So how do we go about doing it? Now, obviously this period was also punctuated with various government reports that came out, outlook reports, the Reef Blueprint first in 2017 and now in 2024, just been released, and this COTS Strategic Management Framework. All of these things have helped us to leverage the government for funding and ongoing secure money for the program. As well as that, of course, there's been a whole swag of disturbance events, cyclones and bleaching events that have impacted the reef and shaken it up to the point where we've increasingly realised that COTS control is something that we can do at scale to keep more coral on the reef now. All right, so as I said, prioritising reefs is probably one of the most important things we need to do in terms of the strategy and tactics of this program. How do we optimise to put the vessels in the right places at the right times? So it's very important that we do that based on the best available science. We draw on numerous sources of data to do that. Field intelligence from the Reef Joint Field Management Program and the AIMS long-term monitoring program is pivotal, as well as that modelling outputs that come. And I don't know if any of you caught Sam Matthews' talk, but Sam's been an absolute hero in developing these dashboards and dealing with all these variable data sources to a point where we can actually interpret it, visualise it, and use it to make management decisions. So it's been an outstanding process and it continues to evolve. But yeah, hats off to Sam and everybody involved. Okay, so where we've landed in recent years is that we've got a long list of priority reefs, and there's currently 500 of those, and they're distributed right throughout the marine park. These reefs are vulnerable to COTS outbreaks at various stages of the outbreak cycle, but they're not all vulnerable every year. So every year we go through a prioritisation process to identify the target reefs, and these are a subset of that longer priority list which we're targeting for COTS control in any given year. These places are at risk from COTS outbreaks now, and they have enough coral on them to justify protection. Okay, so when we get to each one of these reefs, we apply the IPM. The first thing we do is mandatow the perimeter. That allows us to identify where the COTS aggregations are, to steer the cull effort to the right places at the right time, obviously very important. We also use RIS, the Reef Health Impact Surveys, around the perimeter of the reef to give us a bit of a more in-depth picture of coral community structure, impacts to the reef, coral community dynamics. We then deploy the cull teams into those cull sites, and each one of those little polygons you can see around that picture of Davies Reef is around about 10 hectares in size. So we put teams of typically 8 divers. They systematically move through those cull sites in a line. They sweep through, they identify COTS and COTS scars. They find the animals. They give them a single shot or a double shot sometimes of vinegar or oxbile salts, and we kill them. And we move through the site. But we can systematically target and systematically close reefs, and that allows us to work our way through the park. Again, where we go is super important, that the observations that we receive from the field, the reconnaissance that we receive from the RJFMP and the LTMP, super important to us being able to do what we do properly. Okay, and some outcomes that we're seeing so far. Of course, we're actually a couple of hundred reefs a year. We're investing in average years around about 20,000 diver hours across the fleet. So it's a lot of time, a lot of hours. But we are protecting tens to hundreds of thousands of hectares of reef habitat every year. That's a lot of area. So keeping that coral on the reef is incredibly important to empower adaptation of this ecosystem and to allow these winners, the natural winners that pass through these mortality bottlenecks like the current bleaching event, they need to be the ones that spawn in the next generation. Right, so we've seen some outcomes. If any of you caught Sam Matthews' talk, you would have already seen this. I think Roger had this slide up this morning. Essentially on reefs which don't have COTS outbreaks, we see net gains in coral cover each year. Anything to the right of that dotted line is coral covers going up. Anything to the left, coral covers going down. So on reefs which have outbreaks but we do not do any COTS control, we lose coral, and we lose somewhere in the order of 3.5% per year on average with the distribution around it. Places that we attribute effort, COTS control effort to these reefs, we're able to either reduce the loss of coral, essentially halve the loss, or amplify the gains and get a good proportion of the coral increases that we see on reefs that are not outbreaking at all. It's a pretty convincing result. I'd ask everybody not to tweet that or repost it because it's still under embargo. Next week we're all good. You can tweet it to your heart's content, but for now please keep it on the lowdown. Okay, so this is when we're scaling up from an individual reef scale to a region, right? This is the AIMS sectors here, and I'm not going to labour the details, but what you can see is in those green distributions there, essentially you've got the third outbreak in grey and the fourth outbreak in green. In the third outbreak, we had some control, but it wasn't particularly systematic, it wasn't particularly effective across this sort of scale. And it's a pretty big difference, both in terms of the COTS density that we were able to suppress to and the amount of coral we were able to protect. So over the 6 years, from the start of an outbreak at a sector scale to 6 years past, we can see 50% increase in coral cover across that period, noting that this last 6 years or so has been a particularly good time for coral growth and recovery. So that may not be the case when the system's getting increasingly shaken up. Remains to be seen, but for now we know that this can be achieved. Why does it all matter? Of course, when these corals pass through these major mortality events, bleaching, cyclone, others, it's often not all of them that die. There's going to be some that live. For one reason or another, we don't necessarily understand the physiology, the genetics, the reasons why one coral colony has survived whereas its nearest neighbour has died. But whatever it is that's special about that coral that's made it through, we need to perpetuate that. We need to keep that coral in the system. We need to let it spawn, we need to let it produce babies that are then distributed to reefs and replenish other reefs that have been degraded. We can do that at scale, we can do it across hundreds of reefs, but we can't do it without science that informs every step of this program. I'd like to pass over to Mary and let her talk you through some of the work that's been done under the COTS Control Innovation Program. Thanks.
All right. Hi, everyone. So following on from that great deep dive from Dave. Yeah. I'm going to try to stick to my notes so I don't, so I get us back on time. I'll do my best, but I don't want to race through it either. So I'm going to transition into talking about some of the really crucial science that underpins all the incredible work that Dave has just talked about. So you've heard Dave mentioning IPM, and you've probably heard that in reference to the COTS Control Program. This has really been a world-first application of that technique in a marine context, but IPM has its origins in terrestrial agriculture, where it was introduced as in the 1970s as an alternative to using toxic pesticides like DDT. It's a process-based approach that really has 5 key steps, which you see there on the wheel. You need to understand the pest and its biology, things like its life cycle and natural enemies. You need to monitor the pest and its impacts on the environment, develop action thresholds and plans for when and where you'll take action when those thresholds are exceeded. You need to implement controls, and usually in IPM programs, that's a combination of manual, chemical, and biological controls. And then you need to monitor and evaluate the outcomes, assess cost and benefit, and look for ways to improve efficiency. So this is, as you can hear, a pretty information-intensive approach and really requires science to inform every step of that process. Now, as Dave mentioned, under the NESP Tropical Water Quality Hub, that initial research to develop an IPM approach to COTS control on the GBR was undertaken, and really want to acknowledge the really important roles of people like David Westcott, Cameron Fletcher here, and Sheridan Morris in leading that charge. And so with those excellent foundations in place, the COTS Control Innovation Program has really picked up the baton and continued to move forward in advancing all of those aspects of IPM. So CCIP, I'm sure you've heard about it already as part of some of the talks throughout the symposium, but I'll give you a run through of a bit of an overview. It's a collaborative partnership. Collaboration is a key theme of this conference, and ours is a collaborative partnership between GBRF, AIMS, CSIRO, JCU, and UQ, those key research institutions, along with others that have been brought in through an open call. Importantly, it's governed by a steering committee that includes stakeholders in decision-making, traditional owner, tourism industry, and management representation. It's funded through about a $10 million investment over 4 years from the Reef Trust Partnership, and has some quite sizable co-contributions from our research partners. And so we started out in 2020 with a design phase to determine the investment priorities, and then launched into an R&D phase, which is coming to an end in just a few months. So that's an overview of the program structure. We had 3 early investment projects which we invested in while we were doing the design phase, and And then the R&D phase of the program is structured with 3 sub-programs with 24 projects. The prediction sub-program, led by Professor Morgan Pratchett from JCU, is focused on delivering new empirical knowledge that underpins that first step in the IPM, so things like understanding the life cycle and natural enemies of the pest. The detection sub-program, led by Emma Lawrence from CSI Rose Data 61, is focused on developing tools and technologies for detection, so focused on improving the data that underpins the monitoring and the evaluation steps of IPM. The response sub-program, led by Cameron Fletcher, is really multidisciplinary. It delivers innovation in the tools, models, and methods we use in response to outbreaks, so focused on improving the planning, implementation, and also the evaluation steps of IPM. So as you can see or hear from that, the program is pretty multidisciplinary. We've got, ecology and genetics, modeling, robotics, decision science, and social science all working together. And I think Manu had a horrendogram in his talk earlier today, and I think that's a pretty horrendogram too. So I'm not expecting you to read that in any way, but all I wanted to, kind of convey with that is that we have an impact framework that helps to show how all the different parts of the program are contributing to achieving a common set of goals. And ultimately, of course, our mission is to improve prediction, detection, and response to outbreaks, and deliver benefits to the health of the GBR and associated communities. And before I talk about some of the research highlights, I wanted to talk about the fact that the innovation that we're doing comes not just from technically what we've done, but how we go about doing it. So the partnership and governance model for the program really helps to embed principles of collaboration and shared purpose across all those people and organizations that are involved in the mission. The design phase was a really important step because it brought together experts across disciplines to co-develop research proposals. And that, was probably uncomfortable at times because it means that you have to show your cards and trust each other a little bit. But the benefit is that it helps you kind of bridge some of those institutional and disciplinary silos, and meant that we could design a program that has integrated research where we see connections across the projects in the program. So ultimately, the whole is greater than the sum of its parts. And if you're seeing some of the CCIP talks across the symposium, you'll notice a lot of them are referencing some of their colleagues and other work that they're using or is informing what they do. Another important step here is that we've emphasized engagement with stakeholders throughout the research. So researchers, managers, control crews are working together throughout the research process, testing and trialing those new ideas with the people that are going to be using them. And we're also, another theme we're hearing throughout this conference is the connection with each other and the relationships we're building. So we've invested in doing that. So we have regular catch-ups with the team through workshops like that photo there, and most of the people in that photo are here in this room or presenting as part of the projects in the symposium. So I just want to say what a privilege it is to work with all of you out there, and I have, the fun job now of maybe giving a little highlights reel of some of the work that is being done. So CCIP has addressed key knowledge gaps that improve our understanding of outbreak drivers and their management. So Dave has already alluded to this, but Morgan Pratchett and team has led demographic monitoring of COTS populations across 4 regions of the Great Barrier Reef, the northern and far northern Great Barrier Reef, and revealed that there are elevated densities of highly fecund and large starfish in the far northern Great Barrier Reef ahead of the buildup that we're starting to see in the typical initiation zones. So that really suggests we need to rethink our assumptions about where these outbreaks initiate. At the same time, we're investigating the role of natural enemies, so predators, and helping us manage these outbreaks. So, for example, Kenny Wolf, Pete Mumby, and others have collaborated on some work where they've tested over 100 rubble-dwelling predators and identified 30 novel species that consume these juvenile starfish really early post-settlement, including that one that's highlighted there, which is a decorator crab that consumes up to 20 starfish a day, so likely to play an important role locally in population suppression. We've also advanced modeling to explore how protection of key predators, fish predators, things like grouper and emperor, could help us manage starfish populations, and that points towards potential synergies between some of the management levers we have, like zoning, commercial fisheries management, and culling. And Scott Condy presented on that work on behalf of the collaborative AIMS and CSIRO team yesterday. So we've also been working to address a key management challenge in that COTS are cryptic and really patchily distributed in space and time, which makes it really tricky to detect and monitor outbreaks across an area as big as the Great Barrier Reef. So we are investing in development of tools and technology to help improve detection and provide better field intelligence for the control program. This work includes work by Sven Utica and the team at AIMS to develop eDNA monitoring for COTS, which provides a really highly sensitive early warning of COTS on a reef through field sampling that can increasingly be done by citizen scientists and management partners. At the same time, we're investing in development of an end-to-end COTS surveillance system that uses robotics and machine learning to provide geotagged locations of COTS and their scars to control crews for follow-up action. And Zishan Haider presented on that work on behalf of the AIMS and CSIRO team yesterday. And we're investing in calibration across all those monitoring tools in our toolbox. And Emma Lawrence, who's leading this team, outlined the plan for that coordinated deployment, so we have the best possible data to guide the control program's actions at scale. We also have a whole raft of decision support and modeling work, and I'll just highlight a few bits of that here. Cameron Fletcher and team has led the development of a new COTS information system that brings together field-derived and modeled data to better inform the strategic and tactical actions made by the control program. We've also evaluated those ecological thresholds Dave mentioned that are used as our targets for culling to ensure they're efficient to achieve our coral protection goals and also robust to changes in coral growth rates that might happen as a result of climate impacts and ocean warming. And Laura Blamey presented on that work yesterday. We've also used a range of models to evaluate at the large scale how best to deploy the control program's resources across an area the size of the Great Barrier Reef. And that modeling suggests that GBR-wide deployment of vessels outperforms regionally focused strategies, both in terms of the coral area gained and the cost effectiveness of those gains, so per dollar spent. And Tina Skinner and Gabrielle Schiffel presented on that collaborative UQ CSIRO work earlier. Finally, we've also invested in understanding the traditional owner priorities and community perceptions of COTS control for the very first time through engagement with traditional owners across 3 regions of the reef. A team led by Vincent Bacchus and Stuart Lockie has co-designed a framework that highlights traditional owner interests and values across COTS research and management. At the same time, national surveys of more than 1,000 Australian residents nationwide, alongside 140 in-depth interviews with GBR community members, has helped to inform and reveal that while there's widespread public support for culling, people grapple with its perceived risks and benefits. And so that kind of really rich social data has informed the development of a novel social license theory that identifies the key domains that are relevant for gaining and maintaining community support for initiatives like COTS Control, and Henry Bartlett will be presenting on that work tomorrow. Now, there are lots of other talks across the program that I don't have time, obviously, to highlight, and we're already way over time. Hopefully that gives you a bit of an idea of the breadth of the work in the program. So as we're moving closer to the end of the program, we've focused more and more on translation of the research in a management context, because obviously it doesn't stop when you finish that technical report or paper. So we've developed an output register for the program that details the 100 or so outputs of the program and map those into the control program's processes and systems, whether that's strategic planning, engagement, or on-water activities. And so connecting those dots is really helping us all collectively get an understanding of the opportunities for application, and is also starting to spawn the next kind of new research ideas that we need to invest in going forward. That has really, what we've been focusing on now is working collaboratively with managers to develop some management tools that apply those outputs, like some of those dashboards that bring in some of the excellent work of the CCIP team. Let's see. I'm close to wrapping up, I promise. Now, as we're looking to the future, all these partners whose logos you see across the bottom of the slides here have come together recently to develop a 2030 roadmap for COTS research and innovation, and that work was led by Tim Moltmann, who's the chair of our steering committee. And so all of us agree that ongoing research is essential to continue driving improvement in COTS control out to 2030. We have new challenges ahead of us to face. And we've identified 8 priority areas for investment. Of course, we need ongoing baseline investment in those really applied areas of research, so modeling, decision support, monitoring technology, and targeted ecological intelligence. And all of that work needs to be centered around traditional owner priorities. But to ensure we're future ready, we also need investment in innovative control methods like those Dave mentioned earlier. Things like understanding the outbreak dynamics better, especially as we consider their interaction with climate change. And so we're at $4 million per annum. That cost of that research is likely to deliver pretty strong return on investment and really aligns with those kind of overarching strategies that Roger Beeden spoke about this morning in his resilience-based management talk. So wrapping up, one of the take-home messages that Dave and I really wanted to emphasize in this talk was how important collaboration has been for us to get to where we are today with COTS. It's not really that long ago that it seemed like COTS outbreaks were a pretty intractable problem to tackle on the Great Barrier Reef. There are millions of them. Their spawning is incredible, and they do damage at large spatial scales. But despite those challenges, targeted research has really, in partnership with the tourism industry and managers, has really transformed COTS control over the past decade on the GBR, producing some pretty tangible conservation outcomes for the health of the GBR. And it's an exciting time, I think, because we have all these new innovations on the horizon, new opportunities to continue innovating in this space in partnership with traditional owners. And I think, I speak for both Dave and I in saying that we've really loved being able to have a deep dive into some of our apps work over this symposium, and look forward to hearing about the sessions tomorrow and thinking about ways we can all complement each other going forward. So really for, seeing the transformation in this space over the past years has really given me a lot of hope and confidence that if we work together, we can continue to tackle the challenges that come. So thank you to everyone, and particularly all the partners and people in this room that are involved in this work. It's a real big collaborative effort. So thanks, everyone.
Thank you so much, Mary and Dave, for a wonderful talk. We have not much time for questions, but I think we should take 2 from the floor if people have questions. So please make your way down to the microphones. I'll stand awkwardly until someone arrives. I'll rock awkwardly. Surely. Come on. I'm feeling more awkward by the second. Thank you, Carl.
Thanks, guys. I know very little about COTS, but one of the presentations I saw or heard yesterday was around the juvenile COTS, and I was just going to ask is, have we done much work around the juvenile stuff in terms of control, or is it mainly just focused on the adults?
Thanks, Carl. Juvenile COTS are a huge area. I mean, I would say some people would characterize it as a black box. We've started, and there's been lots of work to try to understand settlement and early post-settlement survival of COTS. We're doing a little bit of that in CCIP. There's plenty more to understand in that space, though. I know, right? Yeah, sick 'em.
Okay, any more questions from the floor? Okay, then join me in thanking Dave and Mary once again.